All right, so again, here's a neat wine bottle opener. I mean, a wine bottle stand or a bottle stand. And so this is in static equilibrium. Static equilibrium just means that it is at rest. Well, equilibrium means when an object is in equilibrium, that means the sum of the forces on it are zero, and some of the torques of these forces on it are zero. Okay. Now, so that means what these two equations imply are the linear acceleration is zero and the angular acceleration is zero. Now, the fact that the accelerations are zero doesn't imply the object is at rest. Okay, so what we want is the velocity to be zero as well, and angular velocity to be zero as well. Okay, and when these two are zero, then the object is in static equilibrium. So if an object is at rest, then it's in static equilibrium. If the center of mass of the object moves with constant velocity, then it's in dynamic equilibrium. Also, the center of mass can be at rest, and if the object is moving with a constant angular velocity, then that would be in dynamic equilibrium. Okay. So static equilibrium just means the object is at rest. And of course, we are interested in this because, you know, you build a bridge and stuff like that. And no matter what, let's say if what you want is for the bridge to be at rest, even though your loads might change on the bridge, meaning there could be cars on the bridge, there could be no cars on the bridge. And so that's what we are interested in. And so for our structures to be in equilibrium, in static equilibrium, we can build large buildings and we don't want the wind blowing them down. Okay, so we saw that for extended objects like this, we saw that the two conditions that you need for static equilibrium are that the sum of the forces be zero and that the sum of the torques of these forces be zero. Okay, so let me draw this diagram again. So here's an object, here's an extended object. Let me see. Okay, I'll draw two cases. Okay, so so here's an extended object. In this case, the sum of the forces are zero, but the sum of the torques of these forces is not zero. For the same object, in this case, the sum of the forces are zero, and the sum of the torques of these forces are zero. Okay, so for extended objects, for an object to be in equilibrium, both these conditions need to be satisfied. Okay, and so for instance, here's whatever these things are called, a mobile. These objects have weights to them, and the rods might have significant weights as well. And anyway, since this is in equilibrium in the design, what is gone is the sum of those weights are being balanced by the tensions here, and the torques about any point is also zero. Okay, so that's what's going on. All right, I have a question, so let me pause again.